This example problem deals with a spring that's on a horizontal surface, and there are two unknowns: the force constant of the spring and how much mass is attached to the spring. So when mass m, that's unknown, is attached, and we pull the spring slightly, release it on this frictionless surface, the period of oscillation is 0.477 seconds. Then we attach an additional 50 grams, so it's going to be m plus 50 grams. Again, pull the spring slightly, and the period of the oscillation is 0.551 seconds. We want to determine those two unknowns, the force constant and the original mass. So drawing the two pictures out here, not showing the horizontal surface, but with just mass m, capital M, 0.477 second oscillation, and then we attach 50 grams to m, and we get a period of oscillation 0.551 seconds. The period for a spring, a simple spring, is 2 pi times the square root of the mass on the spring divided by the force constant of the spring. K is the force constant. Well, can I just use 0.477 seconds for t and calculate both m and k? No. Two unknowns, only one equation. I need two equations to solve for two unknowns. So what we do is we write this equation twice. We write the spring period equation twice for the two sets of data. And when we do that, we get the following: 0.477 equals 2 pi square root of capital M over K, and 0.551 equals 2 pi square root of capital M plus 50 over K. Now, is this reasonable that when we have extra mass, we get the longer period? Yes, because we have extra mass here, we divide by the same K for both calculations. We're going to have a bigger number. Why didn't I convert this to kilograms? You can if you want, but the mass units cancel. We don't depend on the units of capital M to be anything. If you want kilograms, then change this to kilograms. But if you want capital M to be in grams, leave this in grams. So I'm going to divide the two equations. I have two truth statements here. Left side equals right side for both of these. I'm going to divide the two equations, a common mathematical technique. So when we do this, we get the times divided and the square roots divided. What can we cancel? Well, the k, the force constant, is in the same position underneath each radical. So that, as I do the processing, will cancel. These two k values will cancel. And I've done the division of the numbers for the time. So 1.1551 equals square root of m plus 50 divided by square root of m. These are capital M's for both of these here, should be. And so we proceed. Now, how do I solve for our unknown m? Well, I need to get out of the control of square root, so let's square both sides. And when I do that, I get the number 1.3343, and the square root symbol goes away on the right side. I've squared this whole side, and we get m plus 50 divided by m. Multiply both sides by m. So the m becomes on the left side with a coefficient of 1.3343. Now, gather like terms, so I'm going to subtract 1m. There's a 1 in front of this m. Subtract 1m from both sides, and we get 0.3343m equals 50 grams. Divide by the 0.3343, and we find that capital M was 150 grams, and I've rounded a little bit here, but that's our situation. So once we have capital M, how can we determine the force constant? Well, we can come back to this equation here. It's a little bit the easier one. And we know the value of capital M now, and we want to find K. But now we need to be a little bit careful. K is usually in newtons per meter. So to come up with the K in newtons per meter, I need to switch the M, the capital M, to kilograms instead of grams to match the standard units that K is expressed in. So 0.15 kilograms divided by K, and matches up with a 0.477 period. Again, I'm going to divide by 2 pi and then square both sides. And again, you should pause the video and use your own calculator to confirm these calculations. And then multiply both sides by k, divide both sides by this number, and I come up with a k value of 26 newtons per meter. 26 newtons per meter. Again, pause the video as necessary, go back and look at it. Do your own calculations. Don't just depend on mine. Sometimes I make a mistake. Please put comments on mistakes in the comment below the video. And ask your instructor if you have questions. If you do have desire to look at some of my other physics and astronomy videos, visit these websites. These are free, no registration. You'll find a list of topics, how long the video is. If you enjoy the videos, please click on subscribe on my YouTube channel.